In the last examples, we took something that was very condensed and expanded it. So it's actually pretty easy to go in the opposite direction. We have, again, multiple logarithms here, and we're going to go ahead and write them in their condensed form. Again, the goal to get down to one logarithm. So here we have in the first example, we have log of 3x minus log of 4y. And we're asked to condense, so we don't want to deal anything with the product right here. What we want to do is focus on this minus sign. That's going to tell us what rule, and namely that we need to apply the quotient rule backwards. Of course, notice for all of the rules, you do need the same base. So if I'm looking at these two logarithms, do they have the same base? Yeah. Both of them have no base written, so it's actually the common log, base 10. So if I want to write them as one logarithm, I'm going to keep the same base, so 10, or nothing to write there. And then I'm applying the quotient rule. The 3x will go in the numerator because the logarithm in front was positive. And then the 4y will go in the denominator. And again, when it comes to multiplication and division, you really don't need the parentheses here, because if you look at this, it's assumed that the fraction essentially belongs to that logarithm. But if you aren't sure, go and write them. That's one of those things that you recognize the natural way that we write them as you deal with them more and more. So now let's go over to the second example. In the second example, notice we have multiplication in front, so we are going to need the power rule, and I would suggest dealing with those first, because those, before you could apply the product or the quotient rule, you need to have the ln's, the natural log in this case, isolated, no product in front. So the first thing you would do is you would have ln of x squared. Then you would have plus, not doing anything with that plus yet, just bringing it down, ln of x squared plus 1 to the 1/2. You may want to just, as you're getting used to this, convert this back to its radical expression. So before I apply the product rule, because of the addition, I'm going to just go ahead and rewrite this as ln of, instead of the parentheses, the square root of x squared plus 1. And really, you don't need the parentheses here, just because the square root is acting as the special type of parentheses that's implying an order of operations. But then the last step would be to just, because we have a matching base e, hence the log of natural or natural log, we would have x squared times the square root of x squared plus 1. Don't distribute, because that special type of parentheses, aka the square root's locking everything inside. And again, you really don't need it here because we assume that the product belongs to the ln, but still good practice just for clarity. So here we have two examples, very similar, a little bit more complicated. You have 3 logarithms, so you'll have to condense down to 1, but I would encourage you to pause the video and try that first. Let's see how it went. So in example C, we again have a value in the front. We have this 2, so I'm going to deal with that first. So this is going to become log base 2 of 5 squared. Then we have log base 2 of 9 minus log base 2 of 75. Of course, 5 squared is 25, so log base 2 of 25 plus log base 2 of 9 minus log base 2 of 75. All right, now let's go ahead and apply our rules. This is positive, and this is assumed to be positive, so when we write these as a single logarithm, namely the log base 2, because they have all log base 2, we are going to have 25 times 9, and then this minus right here means that this 75 is going to go into the denominator. Well, there's no symbols in here, there's no variables, so we can actually further simplify this. So we have 9 times 25, which is going to be 225. So log base 2 of 225 divided by 75. Okay, 225 divided by 75, well, that's just going to be 3. So we'd have log base 2 of 3. You can even maybe begin to see where these rules really allow us to simplify. Because what if maybe when we simplified this, we had something a little bit larger? Say we had a log base 2 of 4 when everything was simplified. Well, log base 2 of 4, you could even go farther and simplify that down to 2. So those are just a few things to keep in mind. This one is simplified because 3 is not a power of 2. And then we have one more example to look at here in D. Notice that this 1/3 is in front of everything, so we're going to have to go ahead and deal with that one a little bit later. So let's see if we can deal with everything inside. Well, we have an ln of x, an ln of x plus 1, and we have a minus ln of x squared plus 1. All of those have a base of ln, or a base of e, since they're the natural log. So the 1/3, I'll deal with that after, because I could apply the power rule after to put it back up on top. But I want to write these 3 logarithms as 1. In the numerator, we're going to have an x times an x plus 1. In the denominator, we're going to have an x squared plus 1. And then we can simplify this further. So we have 1/3 ln. You can say, oh, I can distribute that x. So I'd have x squared plus x. Then you'd have x squared plus 1. And honestly, it really looks like we can do something. And in this case, we can't. If we had an x squared minus 1, you could do something with difference of squares and maybe do some canceling. But we don't have that here. But again, just things to keep in mind as maybe you go through the simplification process. The 1/3 could go up top, so this gives you ln to the x squared plus x over x squared plus 1 to the 1/3, and then just let's see if this isn't a square root because we have a 1/3, but this is going to be the 3rd root of x squared plus x divided by x squared plus 1. And of course, we've condensed this down into one logarithm, so that's how you condense logarithms.